In this video, we're going to determine trig derivatives. In a previous video, we proved that the derivative of sine x with respect to x is cos x, and the derivative of cos x with respect to x is negative sine x. So, let's go from there and start answering a bunch of derivative questions. The first one, suppose y is equal to cos x. We want to determine the derivative of that with respect to x. Well, this is just a straightforward example of remembering a formula. And so y prime will equal negative sine x. And here it is typed out. This next question, y equals x sine x, this is just an opportunity for us to apply the product rule. The first function is x and the second function is sine x. So the derivative will be equal to the derivative of the first times the second plus the first times the derivative of the second. And so we'll get that the derivative is equal to sine x plus x cos x. Okay, and here it is typed out nicely for you. 1 times sine x plus x cos x. Okay, now this next question, we have the sine of x squared. We want to make a distinction between the sine of x squared and the sine of x quantity squared. In this case, the exponent of 2 is operating only on the base of x. So what we're going to do is use the chain rule. For those of you who are purists, we can think of this as f of g of x, where f of x is equal to sine x, and g of x is equal to x squared. Now, if we think of f of x as being sine x and g of x as being x squared, then what we actually have here is f of g of x, literally the sine of x squared. Okay, well, what is the derivative of f of g of x? The chain rule taught us some time ago that the derivative of f of g of x is f prime g of x, g prime x. Well, if f of x is sine x, then f prime of x is cos x. So that would mean f prime of g of x would be the cos of g of x. And recall g of x is x squared, so it would be the cos of x squared. And then we would have to multiply by g prime of x, and since g of x is x squared, g prime of x would be 2x. So overall, we could say f prime of g of x, this part right here, is the cos of x squared, and g prime of x is equal to 2x. And it's important for us to note that this 2x is not multiplying x squared, but rather is multiplying the entire quantity, cos of x squared. So to simplify it, we could call it 2x times the cos of x squared. So there's a lot of writing there, and it could get a little confusing. So here it is nicely typed out. In this case, the exponent of 2 is operating only on x, not sine x. This is a chain rule situation, so the derivative of sine block will be cos block times the derivative of the block. So the derivative will be cos of x squared times 2x. It's important to know that the 2x does not multiply by x squared, but rather multiplies the whole quantity. So really what we have is 2x cos x squared. Now, in the last question we were determining the derivative of the sine of x squared. That's much different than the sine squared of x. The question that we have in front of us here can be expressed this way: y is equal to sine x quantity squared. Well, the derivative of that will just be 2 times sine x times the derivative of sine x, which is cos x. And here it is nicely typed out for you. The exponent of 2 operates on sine x, so we have sine x quantity squared. And as we do the determine the derivative of that, we bring the 2 in front, multiply by sine x, and also the derivative of sine x, and we get 2 sine x cos x as our answer. Okay, for our next question, we have another chain rule opportunity here. Since the derivative of cos x is negative sine x, then that would mean that the derivative of cos block would be negative sine block times the derivative of that block with respect to x. So what that means is, in this case, we're given cos block. The derivative of that will be negative sine block times the derivative of the block. So the derivative of 1 plus x cubed using the power rule is just 3x squared. And it can be a little bit confusing if we leave it that way, because we might be tempted to think that that 3x squared multiplies 1 plus x cubed. It absolutely does not. So instead, it's often convenient to multiply that negative 1 factor in front by the 3x squared, and then multiply that by the sine of 1 plus x cubed. And here it is nicely written out. Okay, we've got negative sine 1 plus x cubed times 3x squared, but because the 3x squared does not multiply the angle, but rather multiplies negative sine of 1 plus x cubed, it's often convenient to write it out as I have at the bottom of the page. Now we're going to take a moment to determine derivatives of the other 4 trig functions. We have the derivative of sine x and the derivative of cos x. Well, the derivative of tan x is like saying the derivative of sine x over cos x. And for that, we have a quotient rule opportunity. We have low d high minus high d low over low low. Now, when we have that negative sine x times negative sine x, that becomes positive sine squared x. And of course, cos x times cos x is cos squared x. So up top, we have cos squared x plus sine squared x, and down below, we have cos squared x. But we know from grade 11 trig identities that cos squared x plus sine squared x equals 1. So what we really have is 1 over cos squared x. If it helps us, we can think of that as 1 over cos x times 1 over cos x. And of course, that's the same as secant x times secant x, which gives us our final answer right here of secant squared x. So the derivative of tan x with respect to x is secant squared x. For our next one, we have cotangent x. Well, this will be another quotient rule opportunity similar to the one we did first, only this time it'll be cos x over sine x. So we have low d high minus high d low. So sine x times negative sine x is negative sine squared x, and negative cos x times cos x is negative cos squared x. So our numerator there gives us an opportunity to factor out a negative 1. Doing that, we get negative times sine squared x plus cos squared x over sine squared x. So that's the same as negative 1 times sine squared x. If we want, we can think of that as negative 1 times 1 over sine x times 1 over sine x. And 1 over sine x is the same as cosecant x. So that would be negative 1 times cosecant x times cosecant x. And that would be the same as negative cosecant squared x, which is what we have right there. So the derivative of cotangent x with respect to x is negative cosecant squared x. For this question, we're dealing with cosecant x. We want to know the derivative of that. So we can begin by simply calling it 1 over cos x, or sorry, 1 over sine x. And 1 over sine x, when we have that expression, we can think to use the quotient rule, or if we prefer, we can use the chain rule, call it sine x quantity to the exponent negative 1. So how would we determine the derivative of sine x quantity to the exponent negative 1? Well, we would put a negative 1 in front and multiply by sine x, and then make the exponent negative 2. But then we would also have to multiply by the derivative of the inside of that bracket. In other words, multiply by cos x. And that gets us to this point right here. And now we have negative 1 times cos x up top, and down below we have sine squared x. So we have negative cos x over sine x quantity squared. So that's negative cos x over sine x times 1 over sine x. And that simplifies to negative cotangent x cosecant x. So now we know the derivative of cosecant x with respect to x. And for our final trig function, we have y equals secant x. Well, that's the same as 1 over cos x. So again, just like in the last question, we have an opportunity to use the quotient rule if we want, or we could use the chain rule. So we've set up this slide to use the chain rule. The derivative of that will be negative 1 times cos x quantity to the exponent negative 2 times the derivative of the inside of that bracket. So in other words, times negative sine x. Negative 1 times that negative factor in front of the sine x gives us positive 1. So we have sine x in the numerator and cos x quantity squared in the denominator. Because of that exponent negative 2, we can put it in the denominator, make it positive. So we have sine x over cos x times 1 over cos x. Sine x over cos x is equal to tan x, and 1 over cos x is equal to secant x. So the derivative of secant x is tan x secant x. So what that does is it gives us 6 trig function derivatives. Most students, in my experience, will memorize those and be able to use them for questions like what's coming up at will. So it's probably not a bad idea to memorize these 6. If you don't memorize these 6, at the very least, you have to memorize the top 2 and then derive the rest from there. Okay, so what if we wanted you to determine the derivative of the sine x cos x? Well, in that case, it would just be derivative of the first times the second plus the first times derivative of the second. And when we simplify that, we would get cos squared x minus sine squared x. And that's what we have at the bottom. Now, if you're really rather clever and remember your double angle formulas, you might remember that that's equal to the cos of 2x. So if you remember to word it that way, that's fine. That's also correct. Or if you word it as cos squared x minus sine squared x, that's also fine. Now in this next question, we have sine x times cos squared of x. So our derivative will be derivative of the first, which is cos x, times the second, which is cos squared x, plus the first, which is sine x, times derivative of the second. So we're looking at derivative of cos squared x. Well, let's move that over to the side and just think for a moment. That's the same as cos x quantity squared. So the derivative of that will be 2 times cos x to the exponent 1 times the derivative of the inside, which is negative sine x. Okay, and then simplifying that, we would get cos cubed x here. That would become cos cubed x. Negative 1 times positive 2 gives us negative 2. Sine x times sine x gives us sine squared x times cos x. And so that would be our derivative for this question here. And here it is worded a little more nicely. We want to use the product rule. And within that product rule, we'll determine the derivative of cos squared x, which will require the chain rule. So cos squared x's derivative will be as shown in red. And therefore, going back to the original question, we can write down that we've got derivative of the first, which is cos x, times the second, which is cos squared x, plus the first, which is sine x, times derivative of the second. So what's the derivative of cos squared x? Well, in red, we're showing it here. It's negative 2 sine x cos x. And putting all that together, everything we have here, and simplifying it, we get that expression at the bottom. Now, in a previous example, we determined the derivative of sine x cos x. That is much different than the question we're about to do. If you're given sine x cos x, you need to use the product rule. But if you're given the sine of cos x, you need to use the chain rule. Some people like to think of it this way. They like to think of it that this question here, they're given f of g of x, where f of x is sine x and g of x is cos x. So if you think of it that way, f of g of x would be the sine of cos x. So that's the situation we have here. And the derivative of f of g of x, as you know, is f prime g of x, g prime of x. Okay, well, if I have f of x equaling sine x, then f prime of x would be cos x, meaning f prime g of x would be the cos of g of x being cos x. And then g prime of x, if g of x is cos x, g prime of x would be negative sine x. And that would make this whole overall derivative be negative sine x times the cos of cos x. Okay? So if you want to see that worded a little bit more nicely, a little bit neater on the screen, this is what we have. We have a trig derivative question using the chain rule. So the way a lot of people think about it is just to say this. Their outer function is sine, their inner function is cos x. So they'll do the outer, so the derivative of sine is cos. They'll leave the inside the same, and then they'll multiply by the derivative of the inner, that being negative sine x. And that line is the same as here. And then just to clarify that we're not multiplying negative sine x times cos x, but rather we're multiplying negative sine x by the whole thing. To simplify it, we'll generally put that negative sine x in front. Last but not least, second last question. We have this one here. Now this one's a little bit longer, and in order to do that, I'd like us just to focus on the fact that we're going to have a product rule opportunity. The first function is tan x, and the second function is sine squared of cos 2x. As you know, when we do the derivative using the product rule, which we're about to, we're going to have to determine the derivative of the first and eventually also determine the derivative of the second. So let's just take a little bit of fast forward and determine the derivative of the second before we even begin. So what we're going to do is we're going to focus our attention on sine squared of cos 2x. I'm going to rephrase that before even trying to take the derivative of it. I'm going to call it the sine of cos 2x quantity squared. Now, when I determine this derivative, I'm going to work from the outside in. So the first thing I'm going to do is move that 2 in front. So the derivative of that, we're going to determine the derivative together here. The derivative of that, I'll move that 2 in front. So it'll be 2 times the sine of cos 2x. Then I'm going to focus on what's inside. So now what's inside, look at it as though you're looking at it for the first time. You've got the sine of cos 2x. So fundamentally, that's the sine of something. So the derivative of that will be the cos of that same something. Now, focus on this like you're looking at it for the first time. Determine the derivative of the cos of something. Well, the derivative of cos block is negative sine block. And we get this. But we're not done yet because we still also have to determine the derivative of that 2x, which is 2. So eventually we're going to do this product rule, and when we do it, we'll remember that the derivative of the second is this expression right there. So if we were to do that overall derivative that you see here, we would have derivative of the first, we now know is secant squared x from earlier in this video, times the second, which is sine squared cos of 2x, leave it alone, plus the first, which is tan x, times derivative of the second, which is this whole long circled expression right here. 2 times the sine of cos 2x times the cos of cos 2x times negative sine 2x times 2. And then we can simplify that. So just to make it perhaps a little bit more clear, we'll show it one more time typed out. In order to determine this derivative, we'll need to use the product rule. Within that, we'll need to determine the derivative of sine squared cos 2x. The expression sine squared cos 2x is best thought of as sine cos of 2x quantity squared. this can be thought of as block squared. The derivative of block squared is 2 times block times the derivative of the block. And this leads us to determine the derivative of sine of cos 2x. To do this, you can think of the chain rule this way. And the point we're trying to make at the bottom here is to show you that if you've got a composite function where there's 3 functions, f of g of h of x, then you can think of it as the outer f prime g of h of x, which is what we've written here. And then the next most outer, which will be the g prime h of x. And then the next most outer, which is h prime of x. Okay, so we're always sort of going from the outside in, we're going until we get to the middle and there's no more further to go. So thinking of it that way, we can think of the answer to our question, which we've already shown in my red handwriting, this way. It's the tan x sine of cos 2x quantity squared, and then we can say derivative of the first times the second plus the first, and then this whole quantity here is derivative of the second. And when you see that, you can take this 2 and this -1 and this 2 and multiply them together, and it becomes -4. We still have that tan x, which is right there. And then we have everything else inside that we haven't yet pulled out. And we have this expression here. And that's the derivative of the original y. And finally, we have one more question. You may recall from earlier in this question, we said that earlier in this video, we said that the derivative of cosecant x with respect to x is negative cotangent x cosecant x. Well, by extension, the derivative of cosecant block with respect to x will be negative cotangent block, cosecant block, times the derivative of the block with respect to x. It's just a simple chain rule opportunity. So in this case, the block is 4x squared minus 5x plus 1, and the derivative of the block with respect to x using the power rule will just be 8x minus 5. And so we can show on our next screen the ultimate derivative. Instead of negative cotangent x cosecant x, we call it negative cotangent block cosecant block times the derivative of the block. And just to make sure people understand that this 8x minus 5 is not directly multiplying with that 4x squared minus 5x plus 1, it's not a bad idea to put this 8x minus 5 in front. So it comes all the way in front here and multiplies by that -1 factor. So we get negative quantity 8x minus 5 times cotangent block times cosecant block.